Good morning, good afternoon, good evening, everybody. Welcome to this series of workshops as part of this hackathon that we're doing, the Dataverse Hackathon. So we've got a series of workshops today. We have Sarah Thiam, we have myself, we have Nandit Mehra, we have Tim Kernell, and we have Debbie Lee. So there's a whole series of talks going on today. They'll be running back to back. Hopefully everything is going okay here. I'm just going to check Twitch just to make sure we are all live. We have Dawn in the chat in the audience as well, so hopefully Dawn can confirm everything is good, and hopefully you can hear everything okay. So yes, Vesga 2007. Hello everyone. Great. So yeah, if you have any questions, put them in the chat as we go along. And I'm going to hand over now to Sarah. So first talk, take it away, Sarah.
Thanks, Matt. Hey, everyone. Welcome. If you're in, I see we have quite a few people around. We're going to kick it off with an introduction and high-level technical overview to FVM. For those of you who, we've done this quite a few times at different hackathons. We've been running a lot of hackathons and we've met a lot of different hackers. So if you're new to FVM, we'll take you through just to get you a gist of what it's about, and then that will give you a foundation to launch into all the different workshops that are happening today, which I'm also personally really excited to view because there's some stuff that we've integrated over the past few weeks, but I haven't had time to like play around with it, and you should be able to do so today. So I would probably stay by my computer and try stuff out, and yeah, I'll be tweeting about it. So there I am on Twitter. I am part of the developer experience team together with Matt and a few other team members of ours, and we focus on making sure the developer experience with the Filecoin virtual machine is smooth. We get your questions answered, and we're creating more docs as we go along and creating more resources for developers as we go along. So your feedback as a hacker is super important. But yeah, let's get right into what the Filecoin virtual machine is about. So overall, I'm pretty sure you've come into this hackathon with an understanding of what the Filecoin machine can do. The Filecoin virtual machine is meant to deliver on-chain programmability to the Filecoin network. And what that means is that for the Filecoin network is a decentralized storage network. We are one of the largest decentralized storage networks out there. And when we talk about on-chain programmability, we're thinking about how you can write logic around the storage natively within the same environment rather than writing to a separate storage platform altogether. So there's a lot of value in that, including things like performance, security. It just makes it a whole lot easier. So that's what we hope to deliver with the Filecoin virtual machine. So now that is what I talked about. I think the vision here is thinking about, not just thinking about maybe one project that we can do, but kind of thinking longer term, if you're thinking about shifting the internet from more of a centralized structure in Web 2 to a more decentralized structure in Web 3, and we want the same capabilities and functionality, we are thinking very much in that spirit. And how can we get to enable web scale solutions with FVM now that we have the whole storage component down? So we do see this as a really new piece in the Web3 ecosystem. And so there's a lot of testing and new ideas that are coming along with it. So very exciting space to be in. We're super excited to have all of you with us at this hackathon. Yeah, if you have not seen this, this is the Filecoin master plan. This is really the goal for the whole Filecoin network. We have built the decentralized storage network, as I mentioned earlier on. So we took about 5-7 years to build that up. It is now running. Some of you might have used it already. Step 2 for us is to onboard humanity's data onto that committed capacity in the storage network, which we are in the midst of doing, and we're bringing on board clients and customers and even people who are from the Web2 space who want to start onboarding data. We are just really good option for them. And if you are curious as to where we stand, we do get questions around like, how do you compare to other storage platforms? You can always go to storage.market. It's a website that can do a comparison for you and can give you a really good understanding of where Filecoin is in that whole space of storage and what we do offer as compared to other options out there. And then step 3 for us is to bring computed data with FVM. So this is the piece where FVM is coming right into. So you are standing right at step number 3 of our Filecoin master plan, and you are effectively part of it if you are hacking today at the hackathon. So to be to just be clear and level set, we are a layer 1. FVM is the layer 1. It is the compute over state off of the layer 0, which is the Filecoin storage layer. And to clarify, we do get questions around the difference between Filecoin and IPFS. And to make it clear for all the hackers today, which will play into your project, is that Filecoin and IPFS are separate. Filecoin itself is a blockchain. It is kind of like the protocol that captures all the different transactions across the storage marketplace, with storage providers that store your data for an incentivized amount of like a fee, right? Whereas IPFS is a P2P network, and so you can store your data and it's mostly free, but the node that is storing your data could disappear overnight, and there's no guarantee of your data being stored. So you have the IPFS P2P network, and you have the Filecoin storage incentivized storage marketplace. The two work in complement. Even if you build your project today, you could be using FVM, Filecoin, and IPFS. So in one sentence, if you think about it conceptually, you could use FVM to then store data onto Filecoin, and you could then pin it to IPFS for a quicker retrieval. Because when you store it in Filecoin, it gets sealed into a sector. To retrieve it, it does take a cost and a certain amount of power to then unseal that data and then retrieve it back out. We have new solutions coming in the retrieval market space, but for now we see that as a really nice complement to then store it on Filecoin, and making sure your data is stored and secure, and then pinning a copy to IPFS for quicker retrievals, especially if you're building a dApp that needs to return information really quickly to your users. So yeah, this is how you can think about the 3 different components. Just to put a point of clarification, because sometimes we do get confused with these different things, and we hope that it's making it clearer to you. So you have your layer 0s, your layer 1s, and I think for most of your projects today, you would be building a layer 2. I mean, of course, unless you are building a layer 1 protocol in complement to FVM, using FVM, most of you will be building a layer 2 solution, and like a dApp or a project. And so a lot of our resources are going to be focused on that. A lot of our workshops as well is going to be focused on how we can help you to build that project out. And this is the classic architecture for FVM that we've shown quite a few times. For those of you who have not seen it, this is a representation of what FVM is and where it sits on the Filecoin network. As I just showed you in the previous slide, we have these are the different layers. If you think about it here, that's represented over here, where you have an instance of FVM running on top of a Filecoin node. So every node could run like an instance or multiple instances of FVM. Within every instance of FVM, this is what it comprises of. So you would have, if you break it down into what do you call it, umbrella components, larger components over here, you can see it such that you have native, well, FVM's over here, and this is what it can do. These are all the different responsibilities that it has, the library that it works with. These are all under the hood. On top of that, you would have 2 classes of actors, and we think of actors like smart contracts. So if you read through our documentation and you see the word actor, we are referring to smart contracts. It is a version of it. I would say we don't have to get into it, but these are 2 different classes of actors that we have. The first class would be the native actors. So we consider these native to the Filecoin network. It was built with mostly with Rust and C++ would be the best languages to interact with these native actors on. Native FVM as a whole. Okay, let me break this down first. On one half of the native actors, you have the built-in system actors. These are actors that are really functioning right now on the Filecoin mainnet. These very much run core functionalities that you need to use with the Filecoin protocol, and are very storage related. So you have things like your market actor, your miner actor, and these pertain to the storage providers on the network, or being able to check out the storage deals on the network itself. So you have built-in system actors that no one can really change except for the engineering team in Protocol Labs. And then you have another class of native actors, which are user-defined WASM actors. So we use WASM time under the hood. And so what this allows you to do is to write with most languages that you're comfortable with that can easily compile to WASM in the Filecoin network. And so that allows you to write user-defined WASM actors using languages that you prefer. And we have a few SDKs available for that as well. We have Go, Rust, assembly script today, and we're still building that out. However, these are not yet ready on the Filecoin mainnet, the same way that the Filecoin Ethereum virtual machine instance, which I will talk about in a second, is. So again, just to quickly recap, you have the built-in system actors, which no one can really change, and then you have the user-defined WASM actors, which in the very near future will allow more people to build out, to define or to write their own smart contracts using the different SDKs that we have. And we also encourage more of the community to build that out. But that should be coming later in the year. But for this hackathon, and the main focus this time around is for this class of actors. So we have built a foreign runtime, which is compatible with the EVM ecosystem. And so we've built out. I'll run through a little bit on what the differences between FEVM. We call it FEVM, so that's how we refer to it in our documentation, versus the EVM. What we've done over here is to make sure that we have an Ethereum JSON RPC API that you can easily use seamlessly with any EVM tooling or technology that you are used to. What it does, and we've also built it in a way that is VM agnostic. So the goal today is to build it to be seamless with EVM tooling and infrastructure and so on. But in the future, we've also built it in such a way that we could easily accommodate different kinds of VMs in the future. And so it's still TBD on what we will be building up next, but we do envision the FVM to be VM agnostic, and you should be able to use it with different foreign runtimes that you are more used to or you prefer. And so what we're really trying to do is to meet developers where they're at, because we do see storage being just important to everyone, right? And being able to enable that kind of web scale solutions with storage plus a VM of developer's preference is going to be a huge game changer for the Web3 ecosystem. So giving you an overview of the architecture, and mostly when you're building in this hackathon, we will be very much focused on using Solidity, using the FEVM, and you'll be mostly building in this space over here. And all your resources will be catered towards that as well. Because I remember we did have some questions yesterday on people asking on what languages they could build in. If you are curious, you could use the SDKs that we have for the native side, but you would probably need to build that in a local dev net that you run. Not impossible, you can still run it. We are looking for users of FVM, so yeah. Okay, and then running through the differences between FVM and EVM, just really quickly, in case you're curious. If you're an EVM dev, you'll be like wondering what is the difference over here. Again, we are trying to meet smart contract devs where they are at. We saw that there was a huge ecosystem of EVM builders, amazing ideas in that space, and we wanted to unlock the FVM for this group of builders. And so we have the Filecoin EVM runtime, aka FEVM. We have a fully feature-complete Ethereum JSON RPC API that has enabled a lot of the tooling that you can use. And I'll run through some of the tooling later on, and it's all stuff that you're going to be familiar with. All our tutorials and starter kits are also built around that. So getting yourself familiar with those is going to make it so much easier for you to hack. We also support address support, account support, and signature support that is fully EVM compatible. So, for example, you could use your OX address throughout all the different development that you're going to do, and you wouldn't actually need to think about converting that to a Filecoin address to be able to use it on our testnet. And then, in the future, if you want to deploy your project to the mainnet, you can still use your OX address, and you're using it all within MetaMask. You just look at Hardhat, Remix. You would really barely see the Filecoin side of things, other than understanding what kind of methods you need to call in your project. And so that's really what we've tried to enable over here. So far, it's been pretty seamless. We are very, I think we're pretty good with like how it's gone so far, and we're always looking for feedback from developers. And we always get this question: why FEVM, not EVM? Again, FEVM allows you to write logic around storage within a native environment. You can all do it within the same environment. Whereas if you were to have EVM outside of FEVM and you needed to use storage, or you have a storage heavy application, or there are a lot of different use cases that you could enable. But if you use just EVM, you would then need to write to a separate storage platform, which could be more costly if you're doing separately, or if, let's say, you're not using Filecoin, etc. is a step away from what you can have natively. And so that is the main difference between FEVM and EVM. Okay, and then what does this mean for developers? So for the first time ever, the Filecoin storage network has been around for a while. There have been more, I would say, a little bit more manual methods in getting your data stored onto the network. Whereas now, this is the first time that developers themselves, and not just storage providers and the engineering team at Protocol Labs, are interacting with the Filecoin protocol. And so, as a developer over here on the left, you would be calling different methods from built-in actors. I mentioned the storage market actor and the miner actor and a few more others. These are built-in actors here, and you'll be able to call different methods on these actors to use within your project. To make it super easy for all of you, we've also we've prepared a Filecoin.solidity library that we've been using for a few hackathons now. So some of you might be familiar with them. Super easy. You can just import the whole library into your contract and then call the different methods using Solidity to then enable methods on the Filecoin network itself. So super easy library to use. We have documentation for that, running through the different methods that are important. And I'm going to touch a little bit on what a storage deal making flow looks like so that you conceptually understand where FVM can come in. And so when you attend all the workshops later on, you would know where you should be looking out for and where, kind of conceptually know where to place FVM and where you should be thinking about what your project can do within the Filecoin network itself. Okay, so running through the deal making flow. So at the protocol level, early days we had this is the original flow. It's kind of like a draft diagram that we've put out. We're going to put more documentation out on this. As you can see, it does take a few different steps. If you look at the column on the left, that is the offline side of things, the off-chain, and then on the right would be the on-chain side of things. And so you're always going in, as a user in green, the little man at the top in green, wanting to store a piece of data, you would have to go off-chain, on-chain, off-chain, on-chain. You have to do a lot of different steps. And every time it comes off-chain, that's like a manual process that you need to go follow up on. And so all in all, that's like a lot of different steps that you need to take to get your storage deal made. I'm not going to go through all of this because life is now easier, and so let's not go through the more complex version of it. But I'm going to show you how you can do it much more easily with the FVM. So this is like our primary programmatic storage method at this point in time. This is going to be, I think, a base workflow for a lot of projects out there, especially because most of them will be storage relevant. What we're really looking for in this hackathon as you build is how do you use unique features of FVM? How do you use unique features of Filecoin? You could build things like DeFi projects and all, but how do you have storage elements or things that are specific to the data economy on Filecoin that are unique, right? So if you are to build like a DEX and it's a Uniswap fork and you're deploying it to FEVM, what special features are there other than it being a DEX? These are questions that we would want to ask as judges and we want to know about. So yeah, running through this base workflow, which could be relevant to a lot of projects here. It's called the client contract method. We have a hard hat starter kit. It is one of the contract templates in there. You could take it, customize it in your project. But what it does, as opposed to the diagram that I showed you earlier, is that it very much streamlines the flow using FVM for you to store a piece of data. So you could, as a user, have your piece of data prepare. You could manually prepare it, or you could, with all the different platforms and applications. And I know a lot of builders are building easy GUIs to use on top of this, which is really cool to see. You could manually or have it covered by the platform prepare your piece of data, because you always need to prepare data before it gets stored onto the Filecoin network, because there is a certain format for it. You could prepare your data, and then you could trigger off the client contract, the FEVM client contract, to get your data stored. The deal is automatically made with storage providers on the network that are running Boost. We could get more into that in the documentation, and you'll see that in the workshops later on. Matt is going to do a really cool workshop on programmatic storage, and you'll see the tutorials being run. So definitely pay attention to that. Zach, my teammate as well, will be running through the data DAO. How you could build a data DAO using client contract as a base workflow as well. He will also run a compute over data workshop, and it will also use this base workflow of client contract over here. So super important workflow over here. as I mentioned, you want to store a piece of data, you prepare your data, you run the client contract. It then makes a deal using, capturing all the details that you want from the piece of data you want to store. It creates a deal with the storage provider, and then it publishes the deal ID back to the user. And as in, the user can go retrieve the deal ID, and your storage deal is made on the Filecoin network. So that very much streamlines the whole process. All you're doing again is deploying the contract. And choosing which piece of data you want to store. So you could use it in various scenarios. If you're building a data DAO, this could be the one client contract that your whole DAO refers to, and they want to store a piece of data. And yeah, it just unlocks a lot of things. So this is our main client contract workflow. They want to highlight that to you, and definitely look out for the hard hat starter kit and the storage deal app making kit. We have all these different application kits and building block kits to help you get started for your project. I won't run through this alternative too much, but there are other alternatives to the client contract. This is not fully programmatic. This does require some manual work, so I won't touch too much into it, but we do have other options within the starter kits that you can use as well. So I'm going to run through some quick tooling that all of you will see as you use in your hackathon. These are really important toolings that have proven effective. A lot of different projects have used them to date. So I'm going to run through some of them so you'll be aware of what you have to use. So we have the hyperspace testnet. This should be the main testnet that you are using. If you do see some other names floating around, like the Filecoin mainnet, the Wallaby testnet, the calibration net, we have quite a few networks running around out there. The main one for this hackathon is the hyperspace testnet. And so you should be deploying most of your projects onto the hyperspace testnet. If you do want to run it on your local net for whichever reason that you have, we have guidance and docs for that as well. That should also qualify for the price submission. So hyperspace testnet or local net, either one you could use for submissions of your project. I would say this is also much easier because it's a testnet that runs for you. And we have storage providers that are mock storage providers that are on this network to then accept your deals, regardless of size and etc. So really good testnet to use if you want. You could very easily go to chainless.org and connect your MetaMask wallet to the hyperspace testnet. If you include testnets when you search and you search hyperspace, you can then get your MetaMask wallet connected as I go through this presentation, and you can start going to the hyperspace testnet faucet and getting some test fill. Every single time you click for test fill, you should get about 5. I would say 5 to 10 is probably all you need, but if you want to start getting more test fill, you could start triggering the faucet right now all the way to the end of the presentation, and you should get like 20 fill or something. But yes, we have a testnet over here. We will be using this in all of our demos. So this is, and we have the Filecoin plus MetaMask integration. It's pretty seamless. As you can see, you're using your OX address and you're getting testnet fill. Yeah, same process. If you're on mainnet, you can see your fill within your OX account. The difference, again, is your contract is being deployed to the Filecoin network, but we are enabling all the different EVM tooling that you're familiar with. So under the hood, you'll still be on the Filecoin network itself, which has its own block time, which is a little bit different. So there are differences, but yeah, do remember that you're deploying to the Filecoin network. So if you're using MetaMask and you're going onto, let's say you do deploy your project to the mainnet, you are dealing with real fill in the future. Super easy. If you want to check this out, you can go to glyph.io, glif.io. You can easily connect your MetaMask wallet. Move fill around if you're taking out from exchange. On our documentation, we do mention what kind of exchanges do support withdrawal of fill to an OX account and vice versa. And if you do hit any snags, the glyph.io page and the wallets that they have over there and the options that they have make it super easy to transfer fill back and forth across your OX account, the OX address, your OX F4 address, F4 being the address translation, if you will, of your OX address to the Filecoin network, and your F1, F3 addresses, which are your addresses on the Filecoin network. So depending on what wallet you have, it just makes it super easy to move assets around. We also have the Remix ID. So if you're used, everything also works on Remix. So if you're used to Remix or you're used to Hard Hat, Foundry, we have different starter kits to support those. And as of today, well, you can just go into Remix and you can use, you can import the Hard Hat starter kit and use it within Remix itself. You can import the Hard Hat starter kit and use it within VS Code, whichever environment you're most familiar with. We also have a parallel Foundry starter kit released probably about 2 months ago. We had one of our early builders help us to build it. From the community, Xiang'an, shout out to Xiang'an. So this is really awesome. So now you have a Foundry option as well if you want. And we're, yeah, if you're a community member and you think something else needs to get built tooling wise, do reach out to us. We'll be very happy to work with you to improve the tooling that we have for FEVM. I did mention Filecoin.sol as a really easy library that was built by our partner Zondex to allow you to access methods on the Filecoin network using Solidity itself. So yeah, they have documentation for this as well if you want to understand every single method and what it does so that you can call it. We have examples and so on. So I love this library. It's just it's easy to use. It makes it much easier. And then we have block explorers. We have about 7 in total. Barracks, Glyph, Philmine, PhilScout, PhilFox. We have various explorers, and these are all captured on our documentations as well. If you head over to the Filecoin docs, you can see the different explorers that support the FEVM hyperspace testnet as well as mainnet itself. And for example, like Starboard, they're starting to capture contract analytics as well. So these are things that you can definitely use to index a network. One of the explorers from Zondex, the Barracks Explorer, has an API that you can very easily use within your project as well. These are all things that we capture in the hackathon cheat sheet, which I'll share right at the end coming up, which should have a lot of easy resources for you to use. And even more FEVM compatible tools that have come up in the past month or so. And we are constantly launching with new partners that are integrating with FEVM. So definitely stay tuned. We use this Twitch channel not just to talk through for this hackathon, but Matt and myself every Thursday get on here as much as possible, get on here and experiment with the different integration partners that are coming in. Most of the time we fail, most of the time I fail, and then he succeeds. But either way, we run through it, and you can kind of walk through the mistakes with us, and we try to capture them as we go along. And we have like guests and everything. So we're gonna be trying out a few of these things. I tried out Docker 2 weeks ago, didn't work. Gonna work on it again, and yeah, just cool stuff. So come in for the Twitch and try all these things out with us. And if you have ideas for other partners that you really want to see, we are on the Phil-Builders Slack channel. If someone pops into the chat, that's where we're mostly discussing and chatting about what builders want to see from us. And some of these options actually came in from those suggestions, so definitely keep those coming in. And yeah, I've talked a bunch. I have a bunch of resources for all of you as well. If you click into the link tree, how do I show this? Let me try to show this. Yeah, if you click into the link tree, you should see one of the hackathon cheat sheet. I think it's a really cool one to check out. So for the hackathon itself, we just updated this 2 weeks ago. It should have all the resources that you need to be able to build, aside from the docs, of course. Like if you want to get started, there's a quick start, ERC20 quick start. If you go to smart contracts, you should be able to find all the different concepts that I just talked about. Mostly, if you need some explainers, we are also mentors on the IPFS Discord, so we can be answering your questions over there. So yeah, either use the docs or also in complement use the cheat sheet to get through what you need for your build for your project. We've also included some not captured on the docs, new different shims or like tools that people have created through hackathons that have been useful. We've included them over here as well. So yeah, definitely check those out. But yeah, a ton of resources for all of you to use. And that's it from me.
Awesome. Thank you, Sarah. Okay. That is great. And as Sarah said, we stream here regularly on Twitch. So if you are new to the channel, you'll see there's a little purple follow button just below. So click on that, and that will